Welcome to Episode 2, the Canine Progression Algebra's First Byte. Could you tell me the difference between these two questions?
Hi, I'm Omar Sotelo. You might remember in the last episode when Robert recorded was aghast to find out that most students in the 21st century believe equal means answer, and that I thought canine progression was a dog. Well, I now know it's not a dog, but I do know that if algebra students believe equal means answer, it can have a strong bite.
Many teachers forget the distinction or don't realize the importance of having students understand the distinction between an expression and equation. Let's look back at the previous questions. Were you able to tell the difference between these two questions? In the first question, this is an expression, a value, or in this instance, a known value. In the second question, this is an equation, a comparison of two expressions, or in this instance, a comparison of two expressions with an unknown.
Welcome back. Let's look at expressions and equations in concrete terms. I have Sarah here with me today. Let's have Sarah open her wallet up for us. Oh, not good. Let's put some money in. Here you go, Sarah.
Gee, thanks.
And here you go, Sarah. Do you remember that expression, 3 added to 7? That's what I gave Sarah, 3 ones and 7 ones. Let's ask Sarah how much she has in her wallet. Hey Sarah, how much money do you have in your wallet now?
I have $10.
But I gave you 3 ones and 7 ones. What did Sarah do?
I simplified.
In kindergarten, students start to learn about expressions by decomposing and composing numbers. Now let's take a look at the following example. Here they are learning to take numbers apart, put them together, or decompose and compose in order to look for and make use of structures using the mathematical practice number 7. In the later grades, the academic vocabulary of compose and decompose becomes known as simplify and factor.
Here are 2 examples. Simplify 8 minus 6 divided by 2 and simplify 3 added to 7. To say 8 minus 6 divided by 2 equals 5 or 3 added to 7 equals 10 are true statements, but it begins the misconception process for students not understanding the difference between expression and equations and thinking equal means answer. Instead, use words like makes, simplifies, or combines too.
Why, Mr. Omar?
Let's go to the bank to find out why.
I've been working hard and saving money for the past 4 weeks. I have $3, $7, $6, and $4, but I don't want to carry all these ones in my wallet. Can I exchange all these ones for a $20 bill?
You sure can. Here you go. Thank you so much.
Thank you.
Hi. In order for that exchange to have happened, both Sarah and Allison had to agree that both their values were the same, or equals. Let's look at that exchange one more time.
Hello, I would like to exchange my 21s.
Perfect. We can do that for you. Would you like 1 20, 2 10s, or 4 5s today?
I think I'll go with 2 10s.
Perfect. 10, 20.
Thank you very much.
Thank you for coming in. Have a great day.
Hello again. In that situation, again, Sarah and Allison both had to agree that their values were the same, or equals. 21s is the same as 120, or 2 10s, or 4 5s.
The concept of making sure equations or number sentences are true starts in kindergarten and continues through college and is even used in other disciplines such as physics and chemistry. It will take time, but it is important for teachers to understand and recognize when students are working with expressions and equations. Expressions don't equal anything. They are simply a value-defined structure in by decomposing, composing, simplifying, or factoring. Equations are 2 or more expressions that must be proven to be the same. How should students answer expressions then? Let's look at some examples. As we see in the first example, the expression example, the reader is asked to simplify, not solve or compare. In the second example, the equation example, the reader is finding an unknown value or evaluating to make the equation. Showing how the expressions on the left and right are equal at 20 is the process all students should understand. In the later grades, these blank spaces are replaced with variables which students are asked to solve for to make the equation true. For example, solve for x to make the equation true. This concept can bring in a whole new set of misconceptions.
Welcome back! We hope you enjoyed our episode on expressions versus equations.
And stay tuned for episode 3 as we talk about myths students build in the middle schools when solving for variables in an equation and how using properties will help correct them.
And in episode 4, where we highlight one of our amazing high school algebra math teachers.
It's critical to watch all episodes in order. Creating a lesson on these sessions without watching all the episodes could result in algebraic misconceptions which would not be supported by the TUSD math department.